In this video, I will be explain you about a theorem that comes under the topic Sturm-Liouville's problem. Okay, so this is a most expected question. So let me start with the statement. So here this is the statement. Determination of lambda defined by lambda is equal to this value is here you have put 3 dashes. Okay, the reason is because already you have equal to here, right? So that is why they are written like that. So also if in somewhere if there is 3 dashes like this, you will read at this as congruent. So here nowhere you will use the conditions or anything based on congruency. So okay, I think this is only to differentiate. Okay, so okay, this value lambda is equal to this equal to this, where here p, q, r are used, right? So these are the functions of the independent variable x. These are the functions. Okay, now in the solution, the first line what you are doing is, or okay, in the proof whatever, let lambda is equal to I1 by I2. You are taking like that because in the statement lambda is in the form of fraction, right? Okay, they are given this equal to this, so you are taking let lambda is equal to I1 by I2. It means you are taking numerator value as I1 and denominator value as I2. So here now delta lambda is equal to, you are multiplying delta with this lambda so that you get this. Now you are differentiating this, okay, so that you will get this denominator value, numerator delta I1 minus I1 delta I2 divided by I2 square. This is what you get when you differentiate this. Now what you are doing is you are giving this I2 square to both the terms. Okay, so that you get like this. Now you can cancel I2 so that you will get this step. Okay, and after that you are taking 1 by I2 common so that you get this term, this so that you will get this, and then delta lambda is equal to 1 by I2. In the place of I1 by I2 you are putting lambda, because in the beginning we have took that lambda is equal to I1 by I2, right? So you are using this here in equation number 1. Okay, so that you get this. Now let I1 is equal to, in the statement you have in the numerator a value, right? You are taking let I1 is equal to this. So here let I1 is equal to this value. Now similarly you are finding delta I1. The reason why you are finding all these things is look at this equation number 1. In this equation number 1 you are going to substitute all the necessary values in equation number 1. That is, the necessary values are here I2. You are going to substitute I2 value here and delta I1 value here and delta I2 value. So you need all these values, right? So that is why now our next intention is to find all these values. So let us start with delta I1. You are finding delta I1 here, so that in the I1 you are multiplying it with delta so that you will get this, and then you are multiplying this delta inside so that you will get this term, and you are splitting this y dash square. Okay, you are writing py dash delta y dash minus qy delta y the whole dx. Okay, now you are splitting the integral, like you are giving this integral to both the terms so that you will get like this. Now you are going to integrate this by using udv formula. Okay, when you integrate this using udv formula, you will get something like this: uv minus integral v du. Okay, I told you the formula. So here it is written like that format. Okay, one thing you have to keep in your mind, at the end write in such a way that at the end the end term should be delta y dash. Okay, all these terms should come at the end of the integral. Okay, so that at the taking common terms from the okay, taking common terms will be easy. So that is why delta y terms should be at the end of the interval. Like that you have to write. So you will get like this, and then delta I1 is equal to this term minus, from this two term you are taking integral a to b and delta y dx common. So because here also you have integral a to b delta y dx, here also you are having integral a to b delta y dx, right? So that from these two terms you can take these common. So that is why here so when taking common you will get this delta I1. Okay, so now our intention is to find delta I2. The reason why you want to find delta I2, because in the equation number 1 you have to substitute these values, right? So that is why. Now let I2 is equal to, from the statement, this is the denominator value that is in the statement. Okay, now delta I2 is equal to multiply this delta value to I2, so that you will get this. Now you got I2 value, delta I2 value and delta I1 values, right? Now substitute all these values in our equation number 1, so that you will get like this. Okay, now what you are doing is put delta lambda is equal to 0. So when you put delta lambda is equal to 0, what do you get? Write delta lambda value, right, is equal to 0. Now what you are doing is write this term as it is, and then from these two terms what you are doing is you are taking integral a to b and delta y dx common, so that you will get this. Now using this you are going to write the relevant Euler equation. So you are writing Euler equation from this integration. Okay, and boundary condition using this. So first let us write the relevant Euler equation. So the relevant Euler equation is this. From where you got this? You got this from here. So this py dash, the whole dash, can be written like this, right? D by dx py dash plus qy plus lambda ry. So you finished writing the relevant Euler equation. So next our intention is to write the natural boundary conditions. So here you are taking this natural boundary condition from here. Okay, the coefficient of delta y is one of our boundary conditions. So here the natural boundary conditions are py dash equal to 0 or y prescribed. So this is how you have to finish writing this theorem. I hope this is easy to learn. Thank you.